Okay, I'm looking today at lab number 11 on transistors. So what I do first is just talk about how our transistor works and remind ourselves of that from our theory before we start into the lab. The transistor specifically is a current amplifier. So the current that travels into the base of the transistor is going to be multiplied by beta to tell us what the current into the collector is. Now what we're going to do in this lab is we're going to go in and we're going to measure this current and calculate beta. So rather than using the given beta, what we'll do is we'll actually calculate beta for this transistor. And we're going to use a very common transistor called a 2N3904. They're a decent but fairly inexpensive audio transistor, a low power one, to make a perfect first transistor to work with. They're very common. They've been around a long time. So if I look at this circuit, what I have is a 1 kilo ohm that goes from the power supply, VCC, that's going into the collector. This resistor will make sure that we keep our current down, but it also makes it really easy to calculate the current, because if I measure the voltage across that resistor, I can just use Ohm's law to find the current. This resistor is from the emitter to ground. Likewise, I can find the current through this very easily. I have a 100 kilo ohm resistor that goes into the base. I use a very large value there because I know my base current should be small. So once again, I'll take this measured voltage and then divide by 100 kilo ohms, 100,000 to get the current into the base. When we're done, we can take the collector current divided by the base current, and that will be our experimental beta. The entire part of the circuit over here is really just to set us up so we can vary this input current. That's all this does. So we use a potentiometer. As we adjust that potentiometer, really going between our input voltage of 15 volts and ground, we can adjust anywhere from 15 volts to 0 on this. We put this 1 kilo ohm in there. That's only to protect our potentiometer, because if we move this wiper up here, this resistance gets very, very tiny here, so we get a big current that flows through that, but that could damage our potentiometer. The 1 kilo ohm resistor is there strictly to protect the potentiometer. It's not really part of the overall bigger circuit. It's part of our practical circuit that we have to protect the test equipment. So you'll want to be careful and make sure you get those in whenever we do things like this, because those potentiometers are built directly onto the board. I'll slide this to the side. This is my 100 kilo ohm potentiometer right here in the board. Well, if I overheat it and it gets hot, that really ruins the whole board because I can't use anything else. So we're just want to make sure we protect it. All right, so what I'm going to do first is I'm going to go set up this part just so I have that input current built, how I can control it. So I want to go up. I've already got on my board positive voltage, ground. And I'm going to go over and I'm going to take this 100 kilo ohms and I'm going to run it one side is to ground and the other side is into a resistor. So I'm going to take one side of this resistor and run it down to ground. I'm going to take the other side, and that's what we would want going directly to power, in theory, but we're really going to put it out here, and I'm just going to grab a 1 kilo ohm resistor. We can see here, brown, black, red. I can measure it if I need to. I'm just off screen, but you can trust me that it's 1 kilo ohm. But it's always worth measuring them for yourself. Interestingly, I say that and it's not measuring. Why is that not measuring? Oh, because the range got misset. Well, my little altimeter is not doing a good job of measuring this. So we'll go ahead and put it on here. It is 1 kilo ohm. I didn't mean to distract with that. So there's my 1 kilo ohm resistor into one side of the potentiometer and out the other. That's this strip here. Now I need to take the wiper and run it through a 100 kilo ohm resistor. So I have a brown, black, yellow over here. And all I'm going to do is just kind of put it off here somewhere. We'll come back to it. And I need to connect the center, the wiper, to it. So that's right here. And we'll bring it over here. So that is this part of the circuit. You'll notice now we're not trying to make a physical representation of this. We're just trying to make sure we follow the connections. That's going to go into the base of the transistor. So I have the transistor right here. Again, it's very tempting for students to want to spread the wires out and connect it and try to make it look like this. Don't do that. If you look down here, this is what's called a pinout that tells you what the pins are. So you can see if you put it on the curved side like this, that the emitter is on this side, the base in the middle, collector is the other side. Or if I flip it over. I think for a lot of people, these are backwards from what they expect, but we just want to follow the pinout. And I will note this is not true of every PNP transistor out there, some of them will be different. So I'm going to put the face to me. You can read right in the front, it says 2N3904. You may not be able to on there, but you can read these. They're small, but you can read them. And so the base is the center one. So I'm going to line this resistor up that goes into the base. And I don't even need to spread these connectors way out. I can just move them a little bit so they're all next to each other. Another common issue people run into is they'll try to put them straight up and straight down. You can't. Those are all connected. So I have them spread just one next to the other. This goes into the base, the center one. I can bend it a little so you can see it. If I go back to my circuit, there's a 1 kilo ohm that goes from the collector to power. So I'll take my 1 kilo ohm that goes from collector up to power. There's also a 1 kilo ohm that goes from the emitter down to ground. At this point, we've constructed the circuit. Now this actually, everything's built and it would work on most of the breadboards in the room. I will just note here that the particular breadboard I have, you can see there's a longer space in the middle and there's a disconnect on the wire. That actually means this side and this side are not connected. There's about 2 breadboards right now as I'm filming this in the room that have that, and the rest don't. You don't need to do this if they don't, but if they do have that, you got to jump for that power. So I'm going to go ahead and turn power on. I'm going to touch everything, make sure nobody's hot. I'm going to come over here. I'm going to take my voltmeter. See why I wasn't measuring my resistors before. I have the wrong connectors. Alright, so I want to get voltage from ground up to positive at plus 15 volts. I'll just connect on the 2 resistor leads directly into voltage. Directly into those. They ought to be able to measure it. So I'm supposed to go to 15 volts according to this. So we'll take it on up. Not sure if you can see it, but I'm up to about 15.03, 0.06. I'll record that. Again, don't round it way off. Record what it is. I'm ready to go. Double check nothing's hot. And I'm going to look over here on the next page and we'll go through what's on this table. So the base resistor voltage. This is not the power. Your power's set, leave it. This is the voltage across the resistor into the base. That's that 1 kilo ohm or 100 kilo ohm. So you want to set that resistor voltage to either be 0 volts or 50 millivolts or 100 millivolts all the way up to 5 volts. Collector resistor voltage. That will be the resistor going into the collector. Collector current. That means you take this voltage, divide by this resistor, which is a 1 kilo ohm resistor, and write your current down. So you'll see that this calculation ought to be pretty easy because you're going to take this and divide by 1,000. Current gain. You're going to take the collector current, divide by the base current. Just take those two, divide them. These need to be in the same units, so they either need to both be milliamps or microamps, and they'll cancel out so there's no current here. I would encourage you to go look up the 2N3904 ahead of time and have an idea what beta is. You can do a Google search and find that, and make sure you have numbers in a reasonable range for it. Now, at the very low end, I'm not going to have any voltage. That means I won't have any base current, so the transistor won't even turn on. So I'm going to expect to see a bunch of zeros here and a gain that doesn't do much. On the upper end, I may have back to this. That's what we call the cutoff, right? It's just off. The transistor's off. It's not doing anything. We get in the linear region where the base current and the collector current ought to go up together, but by beta, so collector current ought to be beta times bigger than the base current. So this will be fairly large compared to this. Probably on the order of 100 or hundreds. Up here somewhere I might hit saturation. Saturation is where there's just no more current to be had. So this collector current won't be beta times the base current because the base is just fully open. It's just running. So I'm going to pick a voltage. Let's pick 500 millivolts right in the middle here. So I'm going to go to this base, and I want to set it to be 500 millivolts. So I'll start turning the potentiometer until I get up to 500. Incidentally, if you have issues getting a voltage here, it's almost always because these connections in here. Either one of them doesn't have enough wire stripped and it's not connecting, or it has too much and it's pushed down in, touching something inside. These connections are the first place I look to troubleshoot this. Alright, so that is 0.516 volts, which is 500 millivolts roughly. I could try to fine tune it. I'll warn you it's very difficult. But there you go. We'll go with that. 0.498 volts, which is 500 millivolts. Now I will take this and divide by 100,000 and write that down as my base current in the first column. Then I'm going to go read the collector to base voltage. That is 0.936 volts. I divide by 1 kilo ohm and write that voltage down, and I divide by 1 kilo ohm, and in the third column I'll get the current. So again, second column's voltage, third column is the current. Then I calculate current gain. I will just go through the entire table and do this. I would encourage you to start really in the middle of the table. I know it's very tempting to start at the top and work your way down, but if it's not working, you won't know right away because you'll be getting 0 and it's off, and that's what you expect. So if you start somewhere in the middle, 200 millivolts, 500 millivolts, maybe a volt, you'll see it. See that it's actually working properly. Let's try one more. So the next one up is 1 volt, so I'll just turn this up a bit and see if I can get up to about 1 volt. So 0.99 volts, pretty close. Divide by 100,000 to get my current for column 1. Column 2 is my collector resistor voltage. 1.901 volts. Column 3 will be that divided by the resistor will give me the current. Column 4 is the gain. My gain should be pretty steady throughout most of the table because I'm in that linear region. Let's just go check. The highest rating I set it at is 5 volts. So I'm going to go all the way up here. Set up to 5 volts. And again, you can just touch things if you want, because if anything goes wrong, all of a sudden you'll get very hot. You notice I reversed my order, so I got reverse polarity, but that doesn't matter. Minus 5 volts, 5 volts. It's just the direction the side my 2 connectors are on. Wow, look at that. 5.00 volts. There's my challenge. See if you can get it as accurate as I do. Oh, it fell off right then. Oh well. Write down my current. Divide by 100,000. Let's go check my voltage up here. 7.36 volts. Divide by 1K. And I can tell you right now it's going to be 7.36 milliamps. And find my current gain. There's a good chance that your beta is going to be less than the others by this point because your saturation, once again. Now I've completed all of table 2 doing the same method. When you're done, you flip the page. The next page, I ask you, hey, search for the 2N3904 datasheet. You've probably already done that if you followed my instructions from earlier in the video. And then you can look up what the beta is and discuss it. You ought to get a number that's in the same range. It won't necessarily be identical, but it will be in the general same range. Okay, that will help you complete the first portion of this lab.